Okay, guys. Well, it's 11 o'clock here in the great state of Colorado. And so we're going to go ahead and get started here on today's webinar, which is the Tsunami2. And we're going to talk a little bit more about our electric version of the Tsunami2 decoders. I've been a modeler since I was a kid. Always push myself and encourage others to try things out and learn new techniques and things like that. Because of that, I've been able to also help out with some of the product development and things along those lines here. So I've been with the Tsunami2 product line, I've been having a lot of fun, enjoying myself, and I want to be able to share some of that fun and excitement with you guys. We're going to talk mostly about electrics today. We're going to cover several topics, including how to set up the sound sets, the dynamic digital exhaust, lesser known features in the decoder, some of the other things you may not know are in there, and then how they can relate to the prototype. We've had a lot of new models come into the market over the last couple of years in modeling electric. Things like the GG1s, of course, have always been available, but we've got other models like the Bachmann Acellas, we've got the AEM7s and some of those type of things. And so we've also always had Trolley. So what we want to do is give you a decoder that kind of covers all of that. And so with that, our Tsunami2 electric can be configured to just about any type of electric locomotive that you can imagine, all the way down from a heavy electric GG1 down to a small trolley or even a small streetcar. And we're going to kind of show you some of that. There are 41 different types of air horns mixed in there. Again, looking and researching prototypes, some of the ones that you see there in the pictures, making sure that those air horns are covered. We've also got 13 different types of bells with a total of 49 different ring rate options. Independent and automatic train brake sounds. We've talked about that with our steam and diesel. We also have it here in the electric. We've also got cab chatter, and we're going to introduce you to Motorman Omura and some of the things that he's going to be performing on our locomotive. All right, so what we're going to do is we're going to play a little bit with the sound setup here. We're going to talk about the Tsunami2. Now, as I mentioned, there is a air horn select, and it's CV120. And again, between all of our product lines, between steam, diesel, and electric, you're going to see a lot of the same type of CVs when it comes to setup. Air horn is set up in CV120. And now I know what you're saying. Yes, okay, some of the GG1s and stuff like that will have air horns and so forth. But actually, there's actually a few trolleys that actually have an air whistle or some type of an air horn on them. They don't usually use it all that much, but they do have it on there. So double check and look at your prototype and make sure you match. And if your model, if you're doing a trolley and it doesn't have an air horn, it doesn't matter what you pick. You can set the volume to 0, or you can take it out of the function mapping chart. It's entirely up to you. Now, there's also different types of bells that you can choose from, and you can also choose the different ring rates. And so CV122, 0 to 48, and if you want to have that horn blow and trigger the bell, say for example on some of the modern, like the ACS 64s or even the Acela models, you can just add 128 to your bell selection and it will automatically trigger. We can also select the type of air compressor, and there's a few different types in there. A light trolley air compressor up to a heavy locomotive sound on it. And then the AC traction motor, there is just one of those on there, but you can do a couple of things. One, it's a humming sound and it kind of follows with the speed, but you can use our 7-band equalizer, and what that'll do is that'll allow you to adjust the overall tone and sounds of this. Now, these sound selections here, I didn't go into the detail as far as which CV values are which, but if you go to our website at SoundTraxx.com, click under the Reference tab, and then you're going to see Manuals. And under the Manuals tab, you're going to find the Tsunami2, and then there you're going to search down to find the Tsunami2 Electric Sound Reference Chart. And this is going to give you what value in CV120 corresponds to which air horns and which bells correspond in CV122 and so forth. So this is a good reference that you can get online. It's free. You can download it, print it off, whatever, and have it ready when you're setting up your decoder. Now, when it comes to setting up the operation, CV114, I'm going to have exhaust in quotes because we call it exhaust, but obviously with a electric locomotive, there's not really an exhaust. But there are some things that you can do. And number one is you can adjust the traction motor RPM rate to basically change, or you can have it increase as you go faster. You can change how fast that RPM sound goes. We also have a feature called dynamic digital exhaust, and we'll talk about that in just a minute. And what that does is that it will basically adjust the overall tone and intensity of that traction motor based on what the locomotive's doing. CV114 also has a traction motor interlock bit, and what that'll do is it'll prevent you from moving the model if your pantograph isn't raised or if your traction motors aren't running. And then the auto start bit, and I want to talk about this really briefly. Auto start bit, when we talk about this in our diesel decoder, it means that the diesel prime mover will start up as soon as track power is applied. Well, on our electric decoder, the pantograph has to be raised and touching the overhead wire before any power can be used on the model. And so the auto start bit in our electrics will automatically raise the pantograph, or at least play the sounds of that. Now on this model here that I have on the table, I've actually got it muted right now. So I'm going to go ahead and unmute. And I'm going to raise the pantograph. Now I've disabled the auto start bit. So when I press the F4 on, you're going to hear the pantograph raise. And then now you're going to hear the other sounds kick on, including the blowers and the air compressor. As all of that works now, because now we've got power applied. Now the other thing about the auto start bit is that when the auto start bit is enabled and your traction motors and everything kick on as soon as track power is applied, F4 is mapped to raise the pantograph. And when you press the F4 that first time, it's not going to do anything, because in this case the pantograph is already raised. So it's up to you to know or to decide which way you want to have your models operate, but you can do both. F4 turning off then would lower the pantograph and reduce the sounds. Now I'm going to go ahead and mute this model for a moment. Now, dynamic digital exhaust allows us to adjust the tone and intensity of the traction motors based on what the locomotive is doing. So when you're on flat level track, the sound will be pretty constant, but then as soon as you encounter a grade, or say if you're pulling a heavier train, that traction motor whine is going to be a little louder and a little bit more intense. So we're going to show you how to set this right now. And I know we have this feature on our steam and our diesel and the electrics all the way across the board, and the calibration process is exactly the same. So on flat level track, we're going to take our locomotive and we're going to move it at speed step 1. With CV32, we're going to set to 2, and this is going to access the 2 dot part of our CV. So now with our model moving at speed step 1, we're going to set 503 to a value of 255. And at that moment, the decoder is going to interrogate the power consumption of that model at speed step 1, and then plot a point on a graph or a chart inside the decoder memory. Now, when we move the decoder a little faster, say speed step 25, 30, something around what you would normally operate the locomotive at, now we're basically going to set CV504 to a value of 255. Now remember, 32 is still set to 2. We haven't changed that, so we can just program 504 to 255. And again, the decoder is going to interrogate the motor power consumption, and it's going to say, okay, at speed step 25, my motor consumes this much power, and plots a second point on this chart or this graph. Now the decoder draws a line between the two of those and says, this is my estimated power consumption for this motor through the entire speed range. And then we take CV512, we set the sensitivity to determine how sensitive the decoder is going to be to changes in the load. Typically on a small trolley or something like that, I'd use a higher sensitivity. On a heavy electric or a freight locomotive, you can use a lower sensitivity, and so that way it takes a little more to get the traction motor to change. So let's do this really quickly here. So we're going to go ahead and unmute our locomotive. Now, typically you want to do this after the locomotive's been running for a few minutes to get the motor and the gears and everything warmed up a little bit. But we're going to go ahead and do this now regardless. And you can always go back and recalibrate it. So we're going to move our model forward at speed step 1. And now with my power cab here, I'm going to program CV32 to a value of 2. And then 503 to a value of 255. Now when I press the enter key, the decoder has already calibrated and knows how much power that motor's using at speed step 1, which is the very base minimum amount of power. Now we're going to go ahead and grab this locomotive and we're going to move it forward at about speed step 20. So you're going to hear the traction motor start to work a little harder, but notice I'm holding it in place. Now with my power cab, I'm going to go ahead and get ready to program CV504 and a value of 255. But before I press the enter key, I'm going to let the locomotive run for a second. We're going to press enter, exit, and then we can hit the emergency stop. And now in that second that I press the enter key, the DCC decoder has now calibrated the power consumption of our model. So now when I take CV512, and I'm going to set this one to this guy, I'm going to set it at 45, just so we can kind of have a feel of what's going on. So I'm going to move it here at speed step 5, and you're going to hear that traction motor kick on. But when I grab it, you're going to hear that traction motor working a little harder now. And when I release, you're going to hear that traction motor changing intensity and tone as we go. Now again, this is a calibration process, so you can always do it again, reset the values, and if you were to go back and read those values of those CVs, they would not be set at 255, they would be calibrated. So again, you can do this a couple of times and find what works well for you, and play with the sensitivity and determine what you like. So with that, we're going to move into function mapping. And when we look at our function mapping chart, you can see a lot of things are going to be very similar. F1 is the bell, F2 is the air horn, F4, as I mentioned, is our pantograph, 5 and 6 is our stop request and pneumatic doors, and we'll talk about those here a little bit later when we get more into the setup for trolleys. F9 is a grade crossing sequence, F10 is a trolley bell, F11 is our brake application, and F12 is our brake select. And you're going to see a lot of similar things here, including general service, steam generator we'll talk about. And then our lights are actually moved up to function 24 through 27. The reason we did that was because most of the time when you turn on a light, such as a number board, class lights, or ditch lights, they're usually left on and then give you the opportunity to run. And then you don't turn them off again until you're done with your run or you stop at a station or something like that. So what this did was it helped free up some of the single button presses like 5 and 6 here for the stop request and our pneumatic doors for some of the more operating things that you're going to do. Now the benefit of using Tsunami2 is you can take any of our functions and assign them to any of the buttons that are on your throttle. So if you want F7, for example, instead of being able to dim the headlight, if you'd rather that to enable cab chatter or sander valve or any of those other things, you can make that function mapping chart look however you want to do it and whatever makes sense to you. The CV is assigned to the effect. So the air horn, the bell, the pneumatic doors, and then the value of that CV corresponds to the button that controls it. So in the case of cab chatter, if we want to move that, we find the CV number for cab chatter, and we're going to set that to a value of 7. And now cab chatter is controlled by button 7. Now the only caveat is it doesn't displace what was on F7, so you can have a button control more than one effect. Any of the effects cannot be controlled by more than one button. And so by setting cab chatter to a function 7, if we want to move the dimmer or eliminate it, we would then find the dimmer CV and set it accordingly. So this gives you a lot of flexibility when it comes to setting up your models. Now when it comes to electric loco Hyperlight effects, there are a few things. F0, as we mentioned, turns on the headlight and backup light, and F24 through 27 turn on the FX3 through FX6 outputs. Now the default light for our headlight and backup light is what's called a diesel light, and basically what it's doing is it's a quick illumination going from off to bright to simulate the element warming up and getting a bright, and it's very fast, so it's one of those that you kind of want to look at closely, but it's different than a straight on and off. Now with our Tsunami 2, we have over 25 different selectable Hyperlight features, including constant dim 1 and 2, which can be used for things like number board lights or interior cabin lights, any of those type of things. You've got strobe lights and many others that we've talked about in the past, including Mars lights, gyro lights, and so forth. Now a couple of lights I want to show you unique to the, that can be used more on the electric. The F11 brake light. And what a brake light is on the back of the trolley here, you can see that the lights are dim, but then when the engineer or the motorman turns on the brakes or applies the brakes, they'll brighten up, just like your cars do when you press the brakes on your car. So on this locomotive here, I've got this backlight on and set up for a brake light. So I'm going to unmute my locomotive here, and I'm going to start to move forward here about speed step 5, so that when you can see it, now when I apply the brakes, you can see that light illuminate and get brighter. When I release the brakes, you can see that light dim and then brighten up when I apply the brakes again. So this is a feature, this is a lighting effect that's actually on all of our decoders, including the steam, the diesel, and the electrics. Most notably, it's going to be used on the electrics because, of course, when you have trolleys and things like that. But if you want to use this lighting effect, say on a rail car or something like that, or a truck, maintenance away truck, you can definitely use this brake light on a diesel decoder as well. Now the one that is very unique and only available on the electric is what's called an electric arcing light. Now, as many of you guys have chased electric locomotives over the time, whether it be the pantograph or the trolley pole or whatever, as it's riding down the wires there, every now and then you'll see this blue arc. And basically it's just the power going through it, or a gap or something or dirt or something is in there and it causes that spark. Now we've simulated that with our electric decoder, so we're going to go ahead and I'm going to hold this locomotive in place, and we're going to move him at about speed step 20. And if you look right here at the pantograph, as we get going up to speed, you're going to start noticing the arcing light. Now this is a really cool sound effect and lighting effect that's timed together, so you can kind of see how that lighting effect works. And it'll just do it occasionally, and so it'll depend on speed, so you have to be going a little more than speed step 5, I believe it is, or speed step 10. But once you're going up in speed, you can get that. So when you mount this little LED up here in the pantograph, you can actually get a really cool lighting effect here with your models. We'll let it play one more time, and then we'll go ahead and bring the locomotive to a stop. Now I do have a little bit of momentum in here. We'll stop it there. We'll throw the emergency stop, and in that case you heard the e-stop dump. So this is just one of the really cool lighting effects that we've implemented into our electric decoders. Next up, we're going to talk about train brakes and the independent brakes. Now every locomotive has two different type of brake sets. Whether, you know, the independent is, as its name implies, is for the brakes that are actually on the locomotive, the brake shoes that actually apply to the wheels of the locomotive and bring it to a stop. And F11 is the brake application, and basically it turns the brakes on and off. Now with the independent or the automatic train brake, that uses the cars to help distribute the braking effort, and so the brake shoes and brakes on the cars themselves will be done through the automatic. And so by turning on the F12, you'll actually toggle into train brake mode. Now when we talk about the independent brakes, these are typically used when you're switching cars back and forth, spotting at an industry, or you can are moving the locomotive through the yard, hustling light, stuff like that. So typically leave F12 off, run your locomotive around, build your train, and then use the F11 brakes. And this uses CV117 as a braking rate to work with or against your momentum to either increase the amount of time it takes to slow down or decrease it. Again, this is all adjustable to decide how you like to run your trains. And so when you use the brakes, you can actually do it. Now here in the case of, say, a trolley or streetcar, there is no train to tie in, and so typically you would really only use the independent brakes. And so therefore what you can do is take the train brake select and either unmap it or just don't press the button and use the independent brakes. Now when you get to the automatic brakes, now when we press the F12, what's actually happening now is that the decoder is swapping over into train brake mode, and this changes the brake sounds that you would hear. And so also at the same time, the compressor starts to cycle as it works to charge the train line, because the cars that are behind the locomotive now would need the air pressure pumped up so that way they can use the brakes. The reason this is called automatic brakes is because the airline is through the train is pressurized. And so when the air pressure is applied in full, the brake shoes are removed off of the wheels. The automatic part comes into play is that when the engineer does a brake set, he reduces the pressure in the pipe, and therefore the shoes of the brakes will actually then grip the wheels of the car. The reason this is done this way is because, let's say for example a coupler brakes or an air hose brakes or something like that, well, you can't go without brakes. And so with no air pressure in the train line, it actually will apply the shoes onto the car's brakes and bring all that cut of cars to the stop. And so the locomotive then won't have cars running at it or behind it uncontrolled. Now when you're setting up your brakes, just use a CV118 for the automatic brake rate, and you can match this with the Tsunami sound cars. So when we have our decoders that are designed for the rolling stock, you can take the brake rate in the Tsunami sound cars, match them to that of your automatic train brakes. So when you're doing your switching, you're using your independent, and when you're doing your train, you can have the automatic. And now when you do your brake set, you're going to hear the air reduction on the cab of the locomotive, but you're going to hear the squealing coming from the cars. So really quickly here, before we move on to the next one, I'm going to show you both of these brakes really quickly. So we're going to go ahead and unmute my locomotive. I'm going to move forward, speed step 10. Now I'm going to apply the brakes, and you can hear the brakes squeal. Change directions. I'm going to release the brakes. You'll hear the air bail off. Locomotive will run, and it'll come to a stop. Now you can feather the brakes on and off, so you can decide where you want to stop. So that way you can couple into your train very closely and very cautiously. Now once I'm tied in, the other thing to note is when you use your brakes more frequently, you're hearing the compressor cycle. So when you use your brakes more, you're depleting the air reservoirs, and so you're going to hear the compressor cycle more frequently. Now once I'm tied onto my train, I'm going to activate F12. You're going to hear the brake system change over, and then you're going to hear the compressor start to cycle. And this is simulating the locomotive charging up the train line so that way your train brakes are ready to go. So in the essence of time, we're going to go ahead and move forward, speed step 10. We're going to release our brakes. You can hear the different brakes sounds, and now when I set my brakes, you're actually going to hear a different sound, and you can see a different braking rate enabled. Same thing, I'm going to change directions here. And I'm going to set my brakes. And again, you can hear the different brake systems as they're running. Now when it comes to electrics, we talked about the pantograph. The F4 enables the sound of the pantograph. We talked about the auto start enabled in CV114. So just so you guys can hear it, I'm going to take the F4 here and I'm going to turn it off. So you can hear the pantograph lowering. And then you hear the blower and those type of sounds now draining off in the background. Now again, with the auto start, when the pantograph raises automatically, you'll have to press the F4 to turn it on before you can then lower the pantograph. Now this particular model doesn't have automatic raise or lower pantographs. If you have a model that does that, you can try to tie in with, like, say, a lighting output that will raise or lower a pantograph and tie it into the F4 as well. So if you've got a motorized pantograph or something like that, you can do it. At this moment with our electric decoder, it's a sound effect, but you can tie it in with creativity and raise and lower that pantograph. So we'll go ahead and raise it again really quickly here just so you can hear it. And now once it touches the wire, we have power again to our locomotive, and everything will start up and start running. So next up here we've got steam generators. So with our passenger operation, when steam locomotives were around, hang on, I'm going to mute this guy now. So with our locomotives running around in steam era, the passenger cars used steam heat and to heat the passenger cars. And so steam was basically pumped through a separate pipe through the passenger train, and that was what was used to heat the cars. Now, when diesels came along, and in this case electric locomotives came along, they obviously didn't generate steam the way a steam locomotive did, and so they didn't have that reservoir to deal with. So what they did was they built a steam generator, or basically a giant boiler with that, so that they can pump the steam heat down through the train. Now function 20 enables the sound of the steam generator, and it's a good sound if you're running passenger trains. This way you can enable it. So I'm going to unmute him so we can hear this, and we're going to turn on function 20 so you can hear the steam generator sound. And that's that kind of whirring, hissing sound that you're hearing there. Then we're going to turn off F20. And it'll basically turn the steam generator sound off. So this is just another one of those realistic sound effects that you're going to get. And with Tsunami2, we have 16 independent sound channels built into the decoder. So all of these sounds will play all of the time. So you don't have to worry about a horn or a bell overpowering a compressor, or in this case, the sound of the steam generator. So general service. Now some of the other things, we're going to introduce you to Motorman Omura, and he is the guy that runs the locomotive, or in the case of the trolleys, and he'll do several general service things like cab door wrenches. You'll hear the lubricators going on and off, AC unit, cab chatter, and more. So when you press the function 18, it'll trigger Motorman Omura to get out and start working on the locomotive. Otherwise you'll hear some of those sounds in the background. Now, if you're modeling an open air trolley like the one pictured here, you can take the AC volume and either turn it off completely, or you can take the probability that you hear the AC unit down to 0, so that way you don't accidentally hear an AC unit in your open air trolley. So you have the customizability to decide what sounds and how often they play based on what your locomotive, or in this case your trolley, might be. So this gives you a little bit more customizability to go through and do some customizing. When it comes to trolley sound effects now, we've got a few that are unique here. We've got F5, which is the trolley stop bell request. So when I press the F5, you're going to hear that trolley stop request. So when your car is moving down the track, you can simulate a passenger reaching up and grabbing on that cable to trigger the motorman to stop the trolley so that you can get off. Now once we come to a stop, we're going to hit the F6 and open the doors. And you're going to hear that sound, and then we turn off the F6 and it'll close the doors. And then F10 is a trolley bell, and you can bip twice for moving forward, or 3 times for moving backwards. So you can adjust in how frequently that sound plays, and you can use that. Now other automatic sounds that you're going to hear, clickety-clack. So if you're doing a small 2-axle trolley, you can do a single truck with 2 axles, and then you can adjust the clickety-clack rate for how far apart the axles are. Same thing for, say, a heavy locomotive with 2 4-axle trucks, or in the case of a GG1, we can do 2 3-axle trucks on the locomotive. So it gives you some customizing so that you'll hear that clickety-clack sound in the background. So let's have some fun. Let's do some examples here really quickly. So we're going to simulate what it would take to start an electric locomotive. So first off, we're going to lift the pantograph. So the F4 we're going to turn on, which we've already done. That'll trigger some of the automatic sounds in the background, like the blower and the compressor we've talked about. F0 turns on our headlight, and we're going to blow our whistle signals. Moving forward, it's going to be 2 long blasts. Now we're going to throw our reverser in the forward direction, make sure we're moving in the forward direction. We're going to turn on our bell. Now if we have a heavy train, this is where we would turn on function 21 for the sander valve. We'll start to move, and then we give our throttle to speed step 1, so it's in theory going to pull the slack out of the couplers. We're going to release our brakes, so the F11 brakes are going to be released. And now we can move the throttle back and forth depending on how long our train is and how much slack is taken out. Turn off the bell once we get going, and then we can increase our throttle and keep going. And you're going to hear traction motors, and then we can turn off the sander valves as our locomotive moves down the track. I'm going to grab our locomotive here. Now, in order to stop the locomotive, let's say we're coming to a station for a stop. And what we're going to do now is we're going to blow our whistle signal as we approach the station, which for a station stop will be a long and 3 short. So now we can reduce our throttle down, turn on our bell as we approach the depot. We'll go a little faster. Now we're going to apply our brakes, and we can come to a stop at our station, turn off our bell, and blow our single short whistle blast to let the train know that we're stopped, we're ready to go. And remember, again, you can feather that brake on and off so that you stop exactly where you want to, so that your passengers don't have to walk halfway down the platform to come to the train. And then when we're ready to go, we basically do the same thing as we did to start it. Now, if we're looking at a trolley, let's see how we would do this a little differently. So we're going to go back to independent brake mode. Now, with a trolley, we've got our pantograph up already. We've got our headlight on. We're going to go ahead and ring the trolley bell like we did. And we're getting ready to go, so we're going to go ahead and move. We're going to release our brakes, and we're going to increase our speed. And we're going to head down the track. Now, as we're going, we're going to get our stop request. And so therefore, it tells us we got to set our brakes. We're going to bring the train to a stop. Now we're going to open the pneumatic doors. We're going to let that person off, and if anybody wants to get on, we can let them come on. Now we can close the doors. We're going to ring our bell, and we're going to start to move, release the brakes, and then we can go back on our way. So now once we've got our locomotive and we've got these sounds in there, you can see how running our trains now is a little bit more interactive and a little bit more fun than just simply turning a knob on a power pack. Now once we add a little bit of momentum for realistic acceleration and deceleration, we can actually activate and use our brakes for mainline freights and use the train line charge, so we can charge and use that. And again, coupled with the sound card, we get some great sounds, and it gives you a full train operation. Now, one of the other things I want to add in is for you guys with passenger cars, our sound car decoders also have 4 lighting effects. So you can do things like the red tail lights, interior cab lights, or even number board lights on the sides of the cars. So it gives you a little bit more flexibility, and all of this can be controlled using the locomotive address. Adding in the sounds and adding in more of these sequences, you're not only being more realistic to what the prototypes do, but it gives you more operation and more fun to do in less space. So many of us, I know myself included, always have a layout that's too small. But now once you add in a lot of these sounds and functions that the real railroads are doing, that small space doesn't quite seem as small as it used to. And again, we talked about function mapping, so you can decide which functions are important to you, map those to the single button presses, and some of the higher functions, 12, 13, 14, whatever, that usually take multiple button presses. You can do some of the things that you would typically turn on or use very infrequently, such as the general service. So in conclusion, with our electric decoders, understanding electric locomotive operation is key to the Tsunami2 development. When we were working on these decoders, we went and did a lot of research with operators who've used electric locomotives, trolleys, and things like that, so that we can make sure we include a lot more of that realism for you. Running your trains is a lot more than just simply turning a throttle knob and using a direction switch, because when we implement the brakes and things like that, you get a lot more fun and enjoyment now out of your models. I mean, we spend a lot of time making sure the models are well detailed. We make these realistic scenery and try to make sure all of this here. So why not use your locomotives in the, properly, like the prototype, in the environment that you've created for them. So makes it interactive, more fun, and overall it gives you a much better fun experience. And with our Tsunami 2, there's a lot of features that are automatic too. So if you do like just sitting there and watching them run, the dynamic digital exhaust will also give you an interactive and a more realistic experience.